Scene Graph is finally here in beta. Scene Graph is the future when it comes to UEFN, and you will need to understand it. Now, if you haven't been up to date or following Scene Graph, you're probably wondering, what even is Scene Graph? What does it change? What can we do with it and how? So hopefully by the end of this video, you should know. Well, Epic puts it like this. Scene Graph is a unified structure that connects all objects in the world. Think of it as a toolbox that contains all the tools you need for the set dressing, gameplay systems, audio, VFX, and much more to create the experiences for the metaverse. In the Scene Graph system, you can instance and reuse objects without Unreal Engine's actor classification. At the core of Scene Graph is a set of building blocks that use data and logic to build your game, as well as render and simulate objects in any gaming environment. Now, in my eyes, if you imagine how UEFN is right now, with how you need to set up devices and control them with verse code, Scene Graph is fundamentally different. Scene Graph relies on entities and components. Now, these are separate to the actors, entities, and components, so just keep that in mind. Imagine an entity is an empty box, and the components are what you put inside of that box to make it do things. For example, an entity by itself with no components looks like this. It's just nothing, an empty box, if you will. But let's say we add a mesh component and also a transform component. Now, when you look at that, we got something completely different, a cube thing. Then in combination with more entities, we can create child prefabs. And then if we get a bunch of those, we can make a custom prefab entity that you can then make instances of and override components and entities of those instances individually. Simply speaking, you can make custom prefabs. Not simply speaking, you can pretty much do anything you want. And also, in the future, there also are plans to expand the components that are exposed to Scene Graph, including like the player's fourth character, which is pretty wild. And I think devices, but I remember seeing that on the timeline like a while back, but I don't know if it's there still. That's what I mean. But anyways, now before we get into it, I need to let you all know, Scene Graph, though being released into beta, it's important to know that Scene Graph does still have a lot of bugs and issues that need to be ironed out. There's a whole document on Epic documentation about all the known issues. I suggest reading through it. At the end of the video, I might just go through every single issue just very quickly. Anyways, that being said though, let's get to it. Now, to start, to actually enable Scene Graph, what you want to do is you want to go up to project, you want to go down to project settings right here, and then inside of here, you just want to scroll down until you find it right here, Scene Graph System. Now, pressing this button will allow us to enable Scene Graph. Now, just keep in mind, enabling this button, okay, don't do it in any project you care about. So do it in copies of projects, or just make a new project like this blank project I'm in right now, and then enable it there. It's highly recommended that you don't enable it in projects that you don't want being like ruined, I guess. You also might notice that up here, there's experimental access, and there's a few little options in here that are experimental. We'll go into that in a second, but for now, I'm just going to click Enable Scene Graph, and that's going to add Scene Graph to my project. It'll take a little second to load, and now when you look at that, Scene Graph is now enabled. Okay, if you remember from the intro, Scene Graph uses entities and components to work. So we're going to make an entity. Now, to do that, there's a few different ways of how you can make an entity and then a prefab entity, which we'll get into in a minute. But the easiest way is just to go up to here to add the project, and then we're going to go down to entities, and we're going to add in an entity, and we're just going to click it into the world. Now, this is an entity. Currently, it only has a transform component inside of it. As you can see right now in the world, it just looks like this. Now, it's important to note that when you summon new entities through Verse, the transform component won't be in it by default, so you're gonna have to add it yourself, so just keep that in mind. But anyways, simply speaking, this is where you'll put all your components into your entity. So for example, we have transform component, and if you go up to here to components, or the plus components, you now see that we have a bunch more components. So we can add in a verse component, capsule light, directional, interactable, keyframe movement, mesh, particle, rectangular light, sound, sphere, and spotlight. So for this case, what I'm going to add is a mesh component. Now, if you see this little symbol right here on the side of these, it's on the mesh, on the Niagara, and on the sound. That's because these are known as asset generated components. So they're going to need an asset to work. So if I go into mesh components, they're going to need a mesh asset to work. So I'm going to grab the cube default one. And as you see now, our entity now has the mesh of a cube. Now, it's also important to note that an entity cannot hold more than one type of components, so we can only have one mesh component in this entity. As you can see, the mesh option is now gone. And in this cube, we have a bunch of different options here, like enabled. This will enable and disable the cube, which means that the cube mesh will disappear. We also have collidable, which changes the collision behavior against players and different things like that. Just keep in mind, I'm pretty sure Scene Graph collision is a bit buggy. I'm not sure how buggy it is. I haven't actually tested it. Just keep that in mind. We also have curryable, which allows it to be curried by verse, so we can check if it's, you know, enabled or whatever. If you turn that off, verse will not be allowed to interact with it. And then finally we have visible, which is just the visibility of the cube. Now I'm pretty sure this will still have the collision on it, so if you want to make it so it's visible and if like not collidable, you want to turn off collidable whenever you're hiding it or something. So just keep that in mind. Anywho's, we have a mesh right here. What we can also do is we can also add in a capsule light. And we can also add in, if you know all the different lights in whatever UEFN, you'll know that there's a capsule light and etc, etc. And as you can see, we can actually move this capsule light away from the mesh because currently this is only a singular entity. So let's say, for example, I wanted to have a light and a mesh and move them independently from each other. How am I going to do that? Now the only way to do that is to make two separate entities. But then if we do that, then they're not going to be in the same, you know, they're not going to be together. So how do we put them together? Well, we're going to go up here and we're going to use this button right here, which is create a new reusable prefab asset that contains this entity. And it's going to create us an entity prefab. And if I click it, it's going to get the entity. We're going to just have to name it something. So cube prefab. I'm going to put it into a folder. I'm making a new one called our prefabs, and I'm going to click it and I'm going to create entity class. So now there's a new folder. As you can see now, we've made a prefab based on our cube right here, which is pretty cool. And now, just to explain this simply, so right now we have our mesh. We also have our light in here. If I'm going to delete this light, I think if I click this and then go to remove component, that's how you delete, by the way. Now the light's gone from this entity, and now we're going to add a child entity to this prefab entity, which is a cube prefab. And we're do that by right-clicking it and going to add entity, and then we're going to go down to entity. Now this will allow us to create a new entity that's a child of this one. That makes sense. So we're going to add in a component, and this time again we're going to do our capsule light, and now it has its own transform component and a capsule light. So now this entity, which is the light, is now a child to our cube. So if I move my cube around, it will now move with the light, and we can move them independently and edit them however we like, which is pretty cool. And again, I can also add a child to this entity, which is like an entity of the child entity, and then this could be another light. Now this light, if I give this a mesh actually, and I give it like a cylinder, it's now a cylinder, and you can now put it on, things like that. So now this cylinder is a child of the light, and this light is a child of the cube. And by the way, the cube is actually a child of the world, or the simulation entity. That's what it's known as, by the way. Just to keep that in mind. It's important for verse. So if you don't know, the simulation entity is like the master of everything. It's the world, it's a simulation. And it's what controls everything. It'll be our light. You can rename it to light, press F2. You also rename this to cylinder, like so. And now we have cool names for stuff. Now, okay, now why did we make this prefab in the first place? What's even the point? If you're familiar with prefabs in Fortnite Creative, you can drag them out and you can make copies of them and everything like that, and it's pretty fun. Now, this is similar to that, where if you go out of here, as you can see now, our prefab of our cube that we placed earlier is now this thing we've just made inside of here. And if I go into my contour, and then if I go into my prefabs, I can see my cube prefab right here. And if I drag it out, as you can see now, I have the new thing I've just made as a prefab. If I go into my outliner now, you can see it in here. It's the same thing that I saw inside of here, the same hierarchy, just in our outliner. And then let's say if I wanted another one, I can just go into my contour and drag it out again, and now we have another one. Now, okay, it's important to note that you can also make a prefab, a blank one. If you go right click here and you go up to entity prefab definition, and you call it like, I don't know, blank prefab, just as an example. You can make one this way. You don't have to make an entity first. You can just make a prefab straight up and then go into it like this, and then add your entities like so. You can do that if you want. You can also add, if you see here, you can do add entity. You can also just go straight up to your prefabs. So you can just add your prefab straight up in here, which is very helpful. Anyways, okay, so now we have 3 prefabs right here. I'm gonna move them. Now, okay, let's say for example, I wanted to change the color of this light to something like red or blue or something. I'll do red. Now I have overridden the light's color, which is the color filter option right here, which is now going to be a little blue dot right there, which means overridden or overridden. And if you look at the top here, there's also another symbol right here, which means at least one of the things have been overridden in the component. You can also see that little like symbol right there in the light. And now in this certain like prefab color filter of the light has been overridden. So if you think about it like this is currently overridden in the current, that one right there. But these light filters are not overridden. So if I go into prefab and I change the light filter to something like yellow, I'm going to notice that back inside of here, if I save it, these are now yellow, but this will stay red because this has been overridden and these have not been overridden. So they're going to inherit from the prefab. And since this one's been overridden, it's not going to inherit, so it stays red. Now, another thing you do is you can also, change transform if you want. So if I wanted to, I can change this cylinder so it's like off to the side on this one specifically. But if I go into prefab and then I raise the cylinder up, and if I save that, you're going to notice that the other two have risen up now. But this one didn't because this is overriding while these inherit from the prefabs. So it's not like if you change one option in like an instance that it's gonna override everything and you can't change anything. It will still inherit things that isn't overridden, even if there's an option like color filter that's being overridden. So it'll just depend on what options are overridden or not. Now another cool thing you can do is you can just completely delete something like this light. I'm gonna delete it. And since the cylinder was a child of that light, it also would got deleted. And now this is actually completely fine. You can do this because what I've just done is I just overridden the fact that those light out of that cylinder even existed in this prefab. So I can still go into here, I can still move the cube like this way, and it's gonna move everything. I can still like rotate the cube like this way, and it'll still rotate the cube, and everything else will rotate because they're all childs and everything, and it'll still all work like that because again, it's still inheriting even though two of them have been gone. Two of them has been deleted. I'm just gonna move this back, and I'm just gonna show you what you can do now. If I grab another cube prefab, this is like the default version. There's a few different components I can add to this. So I'm going to use this entity, the light specifically, two different things. So I can override this if I wanted to. I can remove the component, and I can add in another component. That's a new thing. There's a bunch of different ones. You can add directional light. Interactable component's cool because that's like the thing you can interact with as the player. Now, do keep in mind that this is just kind of like a button you can press. Like, it has a few limitations. It doesn't have an interaction time. If you want an interaction time, go into project and go into project settings and enable enable the scene graph experimental features, and you can enable basic interactive component and tag components, which are two very, very helpful things. Now, just keep in mind again, these are experimental. Won't be able to publish if you have these on, so just keep them in mind. So now, okay, I can now add in the basic interactive component, which is slightly different. It actually worked. Hold on, let me save it, and then let me add a component, basic interactable. And as you can see now, this has a bunch of new options where cooldown per agent, success limit, interactable duration, and enabled, which are a lot more cooler options you can use there. There's also another component like particle system. Problem is that there's no subclasses available for the selected component class. For asset components, you may need to add the content to your project folder. So if I want to add in something like that, I need to right click here and I need to go into Niagara system. I'm just going to make it like a simple thing, like a fountain like this. I'm going to create it. This could also be something you import. It can't be a fab asset. I'll go into that later. I'm going to call this fountain because that's what it is, fountain. And if I, make this again, the particle system, you're going to see again, you're going to get this annoying message. It's because you also need to build verse code whenever you add something new, so SceneGraph can identify it. You just want to build verse code. Once you build verse code, then you want to go back into components, back into particle system, and now we can see our fountain. So we want to click on it, and now we now have our particle system inside of our SceneGraph. And there's also options like enabled, autoplay in editor, and a bunch of stuff like that you can change around. You also have a tag component. Now this is another one of the experimental features, and what this is basically verse tags. So this is very, very helpful for if you have a very specific prop you need to get to or interact with through SceneGraph. Now to actually add a tag, we're gonna have to make a tag in verse first, so build our code, and then we'll be able to select it here and add it to our thing, but we don't have one yet, so it's fine. And then we also have sound components. If I try to add this, it won't work. And okay, no, this is important with sound components is that if you import a sound and then build, you're probably going to find that it doesn't work. If you try to turn it into a cue and then try to make it, build it again, it's also not going to work. What you need to use our sound in SceneGraph is meta sounds. So you want to go to this contour. Now to actually add a meta sound, you want to go into Epic at the bottom right here, and then you want to go to Audio. And we can find meta sounds right here. We'll click on that, and then sources. And then as you can see now, we have two meta sound loop and one shot, which is looping and also just play it once. So what I'm gonna do is I'm gonna make a loop. We're gonna create a meta sound source preset, and this allows us to make a sound. We're just gonna put it inside of our thing. I'm making a folder called sounds, and this is gonna be I'm just gonna call it that, and we'll just put it in there. And now this is our meta sounds preset. Then once you have this meta sound, you want to click inside of it and Okay, so I just got this sound very quickly. If you actually want to add a sound, you want to go find inputs down here, or right here, sounds. And then at the very bottom, you want to override inherited, and you want to add in a sound in here, which is going to be rock destroy. And now we have a meta sound. We're just going to save, and then we're going to build our verse code up in here in verse, build verse code. And now if we go into our scene graph prefab, and then add in a sound component, we should see our meta sound. So we'll just add that, and now we can make a sound in scene graph. And I believe all these settings will change depending on your meta sound. I don't know. I don't think you can even change the meta sound. I gotta be honest. Again, you can go into here. You can change what sounds are in here straight up, like inside of here. And I'm guessing these are randomly play or something like that. You have a pitch bass, pitch random speed, volume bass, volume random spread, not speed, spread. You also have autoplay and then enabled, and a bunch of other cool options for audio there. And I do believe that this audio, you can play through verse, like you can do audio play or whatever. So just look at the verse API very quickly, because I wasn't sure. There is a function to play the sound and stop the sound and remove entity, on simulate, or whatever you want. We'll get into this later. Now that's mostly all the components explained, except for like, you know, verse obviously, and maybe the tag. But the next thing I want to show you how to do is how you can add a custom mesh to your thing. So the way it works is that if I wanted to like say change this mesh of the cube to a different mesh I want, or a mesh I've imported, how am I going to do that? Now it's important to note that you can't use fab meshes, or you can't use Fortnite props right now as I'm making this video, but they should be coming in the future because they're listed as an issue. But anyways, you can only use imported meshes or stuff you make in modeling mode. So what I'm going to do is I'm going to make something in modeling mode. So I'm going to go into modeling mode, and this will be very quickly, don't worry. I'm going to make a torus or something. There's something that looks different. This is our torus. You can do whatever you want with this. This is not a modeling mode tutorial, so I'm not going in depth about it. So I'm just going to accept, and now we have a torus. If I go into my content drawer, there should be a new folder for meshes, and in here we have our torus. Oh, actually, I'm gonna call it bagel. Anyways, so this is our custom mesh we've just made. If you want to add a custom material, go inside of the static mesh and just add it up here into the material slots, like this color. Well, that kind of looks like a donut, does it not? It actually looks like a donut. That's pretty crazy, even as the sprinkles and everything. Well, just go with this. But anyways, okay, so this is the bagel, and if I wanted to make this cube a bagel, what we do is first is we need to delete the old mesh components out of here, and we're just gonna add a new mesh component. And as you can see in here, we don't have the bagel or whatever, so we need to go up here to build verse code. We're gonna build our verse code, and then we go back into here. As you can see now, we have our bagel at the top. You can now see that our bagel is now being able to be used inside the scene graph, which is pretty cool. So that's how you add in custom meshes to scene graph. Anyways, that's it for like the whole like how scene graph works with prefabs, components, everything like that. If you want to know more in depth on how you can build stuff like houses and different things like that, I recommend actually looking at my older scene graph tutorial. So that's how I go more into building and all that in that one. But for the rest of the video, I'm going to cover the verse side of things. So let's add a verse component. If you add a verse component, you want to go into components, and then as you can see up here, we're going to have a new verse component. But clicking this button is the exact same thing as going up to here in verse, going into verse explorer, and going into here and right clicking add verse to new project, and then adding a scene graph component like this. This is the same thing. Anyways, I'm going to add it. As you can see, this is the exact same thing. This component, I'm just going to call it verse. So we have a verse component. And then if you want to create this, you of course create right down here. This is going to open up Visual Studio Code. We're just going to there right now. Now, okay, with Visual Studio Code, this is our components, the basics of it anyways. I'm just going to delete these little words. I know they're like, you know, they're literally designed to clean up the code, but okay, anyways, here's a bare bones basic components with all the different things inside of it. Now, this is not going to go into the basics of verse. Okay, I gotta be honest. You want to go into the basics of verse, watch my verse for beginners tutorial. Just keep in mind, I'm not going to waste my time explaining what var means or something like that. But I am going to go into more detail about all the scene graph specific stuff. But anyways, anywho, as a wild example at the start, this editable right here is a var, has my custom int and an int equal to 10. Now, since it's editable, if I go out and I go back into here, and if I find my verse, where do I add my verse thing inside of this? Oh yeah, I didn't actually add it yet. The current verse component isn't actually added yet. If I want to add it, I want to press components, and then I'm going to find in here, which is our verse component at the bottom. It's going to become a component, so we're just going to add it here. And as you can see now, we have all the options inside our verse component, which are my custom int, and we can change it to whatever the hell we want. Now imagine you can change this to, you know, different things, different editables like devices, stuff like that. Now just to let you know,
adding the verse component straight up inside the entity like this is not going to make it so if I make a new prefab, it's going to have it. If I want to do that, I want to go into the actual cube prefab and then add in the component like this, and then add a verse component like so. That's how you have it for every single one when you spawn in, which is probably what you want to happen. Okay, now let me just briefly go over how verse works with scene ref. Now the first things first, you want to know about component lifetime. Components move through a series of lifetime functions as they're added to entities, added to the scene, and begin running in the simulation. The following states are initialized, added to scene, begin simulation, end simulation, or moving from scene, and uninitializing. So every single component will always go through all of these throughout the lifetime of their life, I guess. Now it's important to note that these component lifetimes are different to device lifetimes, which are like the creative devices. Component logic will run both in edit and play mode, and any behavior you add will immediately run when you launch a session. So that's before the game even starts. If you want component logic to not do that, you can spawn prefabs with the onBegin function of a verse device, which is just a regular old way. And like I explained, they go through different stages, and onBegin simulation would be one of them, which is at the very beginning of the game. Like very beginning. Not when the game starts, or not even when whatever starts. It's onBegin the simulation. So even in edit mode, if you're in a session, it will be playing. And then on end simulation, removing from scene and uninitializing, you can add things that are going to clean up things and etc, like removing things or doing whatever, resetting and stuff like that. Anywho, okay, the first thing we're going to look at is how you can actually look for different components inside your scene graph to like do things. So for example, if there's a light inside of my scene graph, I can then add, I don't know, a particle to it, and I can do that for every single light that I have. Alright, so first things first, I'm just going to get rid of the prints. Now, okay, let's say for example I wanted to find every single light in my scene graph, and then I want to add a particle effect to them. Now keep in mind, this is just for the prefab, but this is not for every single thing. This is just for the prefab. Now to do that, we're gonna have to find every single light. We have to go through every single light, and then for every single light, then we're gonna have to add a VFX particle to the light. Now that sounds hard. It's not actually that hard. So all we have to do is we'll make a for, we'll go down, and we need to call our thing, so light component. This is the name we're going to give to for every single like instance of light components, just like any other for loop. We then need to get our actual like light components. So we're going to do entity get simulation entity, and then we're going to use the one of its functions which is available called find descendant entities with component, and then this is what we're going to put our component into, which would be light underscore component. You see right there. And now we have added in this cool new line of code. Now basically what we're doing now is every single light component that the simulation entity will find inside of our entity will be light components. What we can do then is we'll go down again, and then for everything, what we're going to do actually, we need to create our particle effect. So to do that, we're going to need to assign a VFX. So we'll do VFX. It's going to be this is another component called particle system component, and we need to equal this to anything like any particle system in our UEFN thing. Because if you remember, this is an asset generated thing, or a component I should say. So we're going to use fountain because why not? We already have one here. So we're just going to type in fountain, and then we need to do two little dots right there. Okay, once we have this, we're going to have to initialize our entity. So we do entity, we're going to do equal to entity. Once we have the entity, we're going to now we can do our settings here. So autoplay. So this is the autoplay of the thing. We can make it true or false. So I'll make it true. And then we need to actually then add our components, our entity. We need to add this new entity we just made. Remember, it's right now blank. It has nothing on it. So we need to add in our VFX particle to it. So what we're going to do is we're going to do entity add components, and then we're going to make an array, which is going to be for every component we're going to be adding to it. We're only adding one, which is VFX, so we're just going to do VFX. Oh, sorry, I meant a dot right here. This is a function of the entity. And there we go. So that should be adding things to everything. Now then, all we have to do is enable this, because right now it's not enabled. We'll just do VFX enable, and now that should enable our components that we just added to every single light component that's in a prefab, which is pretty cool. Okay, so very quickly, I just placed down two more prefabs, two fresh prefabs. I deleted all the other ones. And what should happen is that the particle should appear inside of our entity. I believe not where the light is, but on the origin of it. So wherever I think right there, it should spawn in. So we'll see if that works. And then inside our cube prefab, we want to make sure in the very top one, because we're going to follow descendants. So we're going to look through light and cylinder, and light's a light component, so it's going to probably detect light. And we want to have our reverse component inside of here. Like again before, you want to add components, and then you're going to add in our reverse component, which is already added. The custom int doesn't matter. It was just kind of a side effect. It's just, I forgot to get rid of it, but it'll usually just it'll look like blank like this. So we'll just leave like that, and we'll just save it, and then we'll just push our changes. So yeah, here we are in an actual game with push changes, and look, it's working. It found all the light components, or found entities with light components, and it added the particle. Okay, you're probably wondering, actually, it probably just did it because it found things. So actually it proved that it's actually working. I should probably make another prefab and then delete the light off of it. So let's see. And if I go into my session now, as you can see, the middle one doesn't have the effect. Well, these ones do, because again, this one has a light, this one does not have a light. Pretty cool, pretty cool. So now I somehow hope you understand how this actually works and how it actually detects different things, like, you know, if there's a light or not. Now again, remember, this can be anything. You don't have to detect a light, you can detect a mesh, you can detect all the different things that are exposed to verse, which is pretty much everything. And I don't know if you can do this, but you might be able to detect verse components, but honestly, I haven't tried it, and I don't know. I gotta be honest, I don't know. If you want to try it out, you can. Okay, I'm just gonna go back to a blank thing, because we're gonna do another thing. So what we just did was that we found entities using component types, but this time we're gonna try and find components inside of entities. And as an example, I'm going to try and find a mesh component that's currently inside the entity that this verse component is currently in, then manipulate the mesh to do different things. Alright, so this is currently called our verse component 1. I can rename it. It's literally the same file I was using earlier. I'm just going to use it again. Okay, but anyways, so what we're actually going to do is we're going to try and we're going to get a mesh component. What we're going to do is we're going to make it so it basically shows, then it waits a little bit, hides, waits a little bit, and it shows again, or something like that. So it will like appear, disappear, and appear again. To actually do this, we're going to use our entity. So we're going to use an entity like this. It's going to be called it. But the problem is that we want to add functions to that entity that you know, will do what we need to do to make it a lot easier for ourselves. So what we're going to do is we're going to make a function, but it's not like the functions you already know. There's a different kind of function than normal. It's called an extension function. To actually make the extension function, what we're going to do is we're going to get our entity of type entity. Then as an extension, we're going to name our function. So we're going to do dot hide, and then we can do bracket colon void equals. And I've just written out an extension function called hide. Now a regular old function, you'd probably write it out like this instead, then you'd write it out like that. This right here at the front is just, we're getting the entity, which is the entity that the first component is inside of, and we're going to add a function to it called hide. What we're going to do is inside this hide is that we're going to actually find our mesh. Also, by the way, just like any other function, you can add in parameters into here. So I can add an int if I want. So you have that input an int when you call this hide function, and you can do whatever you want. It's similar to how like, you get an agent or a fourth character inside a function, kind of like that. But anywho's, inside of here, we're going to have to find a mesh that's currently inside of our entity. Remember, you can only be one of the type of components in an entity, so we can have only one mesh. So we don't have to make an array or anything. We just do if, and we do mesh. We're going to define our mesh of mesh. And to find our mesh, we're going to do entity dot. We're going to use the inbuilt function called getComponent, and then we're going to do brackets mesh component. Now we're going to do the brackets like that is because it's failable, and this could fail. That's why it's inside of an if. So now mesh is going to be equal to our mesh component if there is one. And then after that, we're going to do we're going to get our mesh, and then we're going to use an inbuilt function inside the mesh component, inside the API called disable. And like before, with the little buttons, like these check boxes on the inside of the UEFN, we can call different API functions of the mesh component here. Now if we can find it here, if you hold control and hover over mesh components, you have all the stuff you can do with mesh components. So you can do enable, disable, is enabled, collidable, queryable, and visible. You can also check if it is enabled or not. You can also get the events of the entity entered event, entity exit event, and a lot of really useful stuff like that. And you can go through all of this digest, so you can get the particle system, you get the rectangular light, you get all the different things you might want to use with different components. So it's very, very, very useful. You can also find all this information online in the documentation API, like breakdown that I showed earlier. But anyways, in this specific case, we're going to use disable because disable will hide it anyways, and it's going to disable everything about the components. So it's going to disable the mesh, it's disable the the visibility and the collision as well. And now, after this, we're just going to copy all of this, and we're going to make another function, but this time it's going to be called show, and we're going to do the exact opposite of what we just did, and we're going to show the thing. Instead of disable, we're going to do enable instead, because we're going to be enabling the mesh, which is showing the mesh. I know if you wanted to set the visibility, I should probably let you know. You wanted it, since it's a variable inside of here, so where is it? Right here. Since these are variables, we can set them to something. So, for example, collidable. If we do set mesh.collidable, and then we can do equal or true. And now since we set it to true now, remember this collidable is a boolean, I do believe, or is a logic. So yeah, it's a boolean. So you can set it to true or false. So we can set it to true, or we can set it to false. And that's how you would mess around with booleans or something, or things that are variables. And that's generally how you screw around with it, like really anything. So if you had a light component, you might want to do like set the light color to something or whatever. You know what I mean? The color filter. Actually, I'll do that in a second. I'll show you how to do it in a second. But anyways, now that we actually have our functions, what we're going to do in non-simulate up here is that we're just going to make a loop. And then inside of our loop, what we're going to do is that we're going to make a sleep, and we're going to make a duration for this. We'll do 2 seconds if we want. But what we can also do, instead of 2 seconds in here, we can make an editable up here. That's going to be for duration. And we can make this a float. It needs to be a float because sleep takes floats, not ints. And then we can do equal to, 2. That's going to be the default one, and you can add later on for every single first component, you can override that to have a different duration for every single mesh. So then we're going to call this duration in here because we've already defined it up there. And then our second thing, we're going to do entity. We're going to call our new functions we've made hide. We do hide, and again, if you had any parameters, like if there was an int that's supposed to go into this, like so, or I'm going to need to put an int in here, so we do 2. Or I should call this like number. Yeah, there we go. If you call it int, it messes up. And then, so then we could do like print, number. You instantiate that into there. There we go. Is that the right? Is it instantiate? No, it's a different word. I forget the word. It's an I word, anyways. So you can do something like that where you can get you put in your parameters of the function in there, and then you can then use the parameters down here. So then when this function is called, and whatever is inside of here will then get said, because that's our int that we're putting inside of it. Again, you can also then make that another editable up here, and then you can put that straight up in there. So you can do editable. I'm just showing you what you can really do, but it's not like anything crazy. Our editable is that, so then we can do number. So our editable number, we can change inside of our scene graph itself, and we can override it, so then it will print out and change the mechanics of how hide function works. Stuff like that is kind of cool. Then I'm not gonna do it again, but I'm just gonna do sleep duration. Literally, that's just for the example. You don't have to do that. And then we do entity again because of the loop. So it's going to sleep, hide the thing, sleep, and show the thing. So we're gonna do show function we made, and we just do brackets because there's no parameters for that one. So we just do, and then this should be functioning. So we just want to build our verse code. Now back in UEFN, since we've overridden our verse tag, the particles won't show, and instead it's going to try and find a mesh component in each entity. Since the verse component is inside of our light, it's not going to find a mesh, so it's not going to work because the light entity doesn't have a mesh inside of it. So we find it here. As you can see, light, our verse component's inside of here, but it's not actually. Where's our verse component? I was just completely gone. Oh, okay. I think it might get deleted when we do that. Who cares? I'm gonna delete both of these, and I'm just gonna go back to the cube, and I'm gonna add our component in, which is our verse component 1. And as you can see now, in our verse component 1, we have the duration, so we can change duration. We also have our number as well that we can also change. So the cool thing about this now is that if we have editables in verse, if I just delete like 2 of these, and I put I put this right here, and we can add in like another cube prefab. I don't know if you can do alt drag with these. I gotta be honest, because I remember that broke or something that made it break back in like the beta or the experimental mode of scene graph, but I don't know if they fixed that. We'll just test it now. But inside of our verse component in these now, we can do, instead of 2, we can make this 4. As you see, we've overridden the editable, and this one we can make it 8 or something. So we can change the verse inside of here without needing to go inside the verse and do whatever. We can inherit from things, and this is the power of scene graph. Imagine this, but for like hundreds of things, whatever you want. Like it's pretty crazy. So after this, I'm going to push my changes, and I'm going to go into session. And now you can see in game, this one's going on 2s, this one's going on 4s, and this one's going on 8s. So that's pretty cool. So this one's always going to blink the most. This one's going to go like, you know, halfway, and then this one is going to work every 8 seconds. Sometimes they match up, other times they don't, which is kind of fun. So yeah, and if I were to walk onto these, you're gonna notice that the collision is, it seems to be working somewhat. So it seems like the collision is actually working now. So I don't know about raycasting or anything like that, but it's pretty interesting. Or whatever it's called, the mesh casting. So yeah, anyways, it seems like this is working. So like something like this you could just use for like a platform thing. If you're making platforming, now you can make like this as a platform, and then you can just make a little parkour course if you wanted to. Oh, so like I said earlier, I'm gonna show you how to make it like so. What we can do is we need a light, and then we do equal to entity dot get components, then we do the light component, and there we go. And then instead of here, then we can do set light dot something like, I don't know, we have to get the certain setting, I think color filter. If I go into prefab this very quickly, and what I can do is inside of the same component, I'm just gonna add in a light. Sorry, light component. There we go. We got a light, and then this light, I'm just gonna leave it inside of it. You can't move it. And then it's called color filter, and I'm pretty sure we can change all these settings if we want, but I'm gonna do color filter for this example. And we'll do color filter is we can set it to, I believe, what we're gonna use is called something called named colors. I'll just look to the API for this, and we can get a color like red, and I think I've actually. Now this is going to give us an error, but you're going to notice that we have to use a module called verse.org/colors, so we're just going to add that. And there we go, we've added the verse.org/colors module, and now we can change the colors of the light to, you know, named colors red. And that's how you would change something like that. And you can do that with pretty much everything. Anything you can change, you can do this. You can just look at the API if you want by just holding control and going on, I believe, light components. Like again, you can change the color filter here. I'm just adding in the colors. I can just like cast shadow, you know, specular scale, diffuse scale. Again, enable disabled is enabled, and you know, there's a lot of stuff there. You want to go check it out? And it's also important to mention that the light component is actually a superclass that includes directional light, capsule light, sphere light, rectangular light, and spotlight. So just keep that in mind. And let's say if I wanted to find a very specific light, instead of doing light components, I can do capsule underscore light components instead. And I can find these very specific things if I want. Or I can find directional light, like directional light. And you can do it like that if you don't want it. If you don't want to find every single light and you want to find only a specific light, you can just do it like that. Alright, so back to this. Let's say I wanted to find every single component inside of my entity, so I can get them all into a nice little array, and I can do whatever I want with them. The way you can do that is, firstly, we want to make an array, so we're going to call this our component. We're going to call this our component list. We're going to equal that to our entity, and we're going to use an input function called get components instead, not components, components. And then we'll do brackets. So to actually go through each component in this array we've just gotten, we've called component list, we're going to use a for loop, and we're going to just go through each one. So what we're going to do is we're going to get 4 components in the component list that we just find up there. Let's say if you wanted to find every single component that's enabled and disable them, we can do something like this, where we can do enableable component. We do it like this, so we do equal enable, and we do a component instead of here. Sorry, wait, that's not capitalized. We then want to do, and then we're going to disable every single enabled component. So we're going to do enableable components. And this will only have a component inside of it if we've actually found a component that is enabled in our list, and then we can do the disable, and now we've disabled the component. So to break this all down, first we're getting a list of all the components that our entity has. Then for every single component inside of our list, we are then finding if it's enabled or not. Then if it is enabled, we're going to then disable it. So we'll have everything at the end by disabled, all enabled. So that's how it works. And you can do whatever, and you can use this for whatever you need for each. Oh yeah, and also just for your information, enableable is an interface, and this you can do enable and disable through it. It's not just for enable. That's why the disable. You can also do you can also find everything that's enableable, and then you can also then do enable. So you can enable an entire entity instead. It'll still work. Oh no, and also my explanation was kind of wrong. It's not finding everything that's enabled. It's finding everything that has an enabled interface, you know, inside of it. But anyways, so you can still find stuff that's disabled, if that makes sense. It just needs to have the enableable interface inside the component. Alright, so I'm just gonna remove all this again. And the next thing we're going to cover is how you can actually tag different entities using the tag components. Okay, like before, if you want to actually get the tag components, you want to go to project settings, and in here, you want to scroll down a little bit. Now you can find in here the scene graph experimental features tag component as right in there. And make sure you have this enabled if you want to use tags, but just keep in mind that it is experimental and you won't be able to publish with it if you have it enabled. But tags are extremely useful to be able to do whatever you want. Anyways, to create a tag, it's similar to how you do it in verse normally. What we're just going to do is we get to make a new verse thing. So we're going to verse our first. We're going to right click the top of it, and then we're going to add a verse file to project. And this is going to be a regular old verse device. And this is going to be our, I'm going to call it our tags list. That'll do. And this is going to contain all of our tags, and we're just going to create it. Now then we're just going to here to open it. So alright, inside our tags, then we're just going to delete pretty much everything in here. We don't need any of this. And we're going to make our tags inside of here if you want. So tags are classes. So what we're just going to do is, I don't even think you need this also. You can get rid of the first things first. We're going to implement our tags module. So we're going to do using /verse.org/simulation/tags. And that will give us our tags. Then we need to actually make our tag, and it's a tag is a class. So we're gonna make a tag. I'm gonna call this our scene graph tag. This is gonna be the name of our tag. Then we're gonna do that equals to class, and we're then going to inherit tag interface. So it's gonna be tag and then colon. Oh, sorry, tag. There we go. Now we now have this scene graph tag inside of our project. Now this is the name of the tag. This could be anything. This could be box tag. This could be, you know, tag. Blah 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 blah. You can call it whatever you want. This is the name of your tag anyways that first is gonna locate. I will just save it like that. And I made this file because then inside this file, then you can put all your tags in. So you can do like this. If that makes sense. You just put all your tags inside of it. Not like that, but you know what I mean. Kind of like the first two. Just make sure they're not named the same so that it doesn't get confused. So this is like box2 tag, and you just put all your tags in here. I'm just gonna use box tag for now. Then okay, back in UEFN, if we just want to build our verse code, and that's gonna add our tags to UEFN. And then what we're just gonna do, like usually what you do with tags is that you get something like a cube, and then you go to details, and then you scroll down, and you find where is it, verse tag markup, and instead of then here you do tags, and you can find our verse box tag we've made in here, and you add it to this. You add the tag of box tag to our box, like that. That's how you'd normally do it through verse. Now scene graph is pretty much the same thing, but if you just I'm just this. If I go into my actual if I go into content drawer, cube prefab, and inside of our cube I can add in, I'm gonna delete this because I don't need it. I'm just delete the light. There we go. And inside our box, what we can do is we can component, and this is going to be a component inside of our entity, and we can go down all the way to the bottom to tag component, and we add in a tag that we've made, and we go into here, and let's look at that box tag. We can give this entity a specific tag called box tag, which is made, and this could be anything. Now another thing you can do is that this is tagging now every single prefab I make. So if I add it in a prefab now, you see our tags are up here in tags. It's kind of weird how it loads, and you gotta move this out. There we go. And I can see our tags there. But if I copy this and I remove the tag, this one is tagged still, and this one has been overridden where it has no tag. So whatever we do in verse with the tag, it'll only affect this one and not affect this one, because again, this is not tagged, but this is tagged. So tags are very useful to making it so you can change certain like prefabs. Okay, now you're probably wondering, how do we actually use this tag in the side of our scene graph verse component? All right, so back inside our our verse component. To actually use the tag, easiest thing is that we're just going to get the simulation entity, and then we're going to find things that have the tag. So we're just do if we then get simulation entity, we're going to equal that to entity get simulation entity. Oh yeah, and by the way, I mentioned this earlier, but this is a way you can use the simulation entity to find every single scene graph inside of your game. Forgot to mention that, but anyways, this is getting the simulation entity. So the simulation entity is like the master. Okay, that's the highest thing, and every descendant of that is basically every single prefab entity you have in your map. So this is perfect for finding where tags are. So we're going to then we need to get all the tagged things. So if you want to get all the tagged, we're going to make this is going to be an array. So we're going to get an array of all of our descendants that are tagged equal to we need to get our simulation entity, find descendants entities with tag. Oh sorry, I spelled that wrong. Entities with tag, and our tag is in here, so we can call this our box tag. This is what it's called, box tag, and we do colon. So now this is going to find every single entity with our box tag, and it's going to put into an array called tag descendants. And then from there we can then do what we just did last time and then make it so we can then change stuff about our anything with box tag inside of it. So for example, like we do we could do for tag inside tag descendants. So we're going to get like, you know, 4 tag descendants, which is our thing. We can do, and then again, we can do something like enabled. We can then get enableable tag is equal to enableable. We can do enable, and then we can get our tag there. Oh, sorry, actually I did this wrong. We want to put this instead of here. It's not working. And then for our for every single enableable one, we're gonna get our enableable tag, and we'll do disable. We might want to disable everything. Also, sorry, by the way, I did equal. This shouldn't be equal. There we go. And now it should work. So now we're getting every single tagged object in our map on simulate, and then we can then do, you know, enable, disable, and do whatever you want with everything. Find a certain kind of component inside of it and do something like that. You can do whatever. That's how you would use tags. All right, so next thing I'm going to do is that I'm going to try and make a button that I can use that is on this mesh. And if I click the button, a light will turn on and a light will then, and if I click it again, the light will turn off. Now to actually make this, it's a bit more complex than normal. So this might be the most complex thing in this video anyways. First things first, we're going to go into our cube prefab, and I'm going to grab out a interactable component. I'm going to use the basic interactable for this video, but you can also use the interactable down there, but I'm just going to grab this. And inside of here, we have a bunch of different options like cooldown per agent, success limit, interactual duration, enable. Now, I should probably also mention that to actually get this, if you didn't see from earlier, you have to go into project settings and you have to scroll down and you have to enable the experimental scene graph features, and then you'll get the basic interactable component. Just keep in mind that doing this will not allow you to publish your map, so just keep that in mind. But anyways, if you don't want to use this one, this has cooldowns and like success limits and stuff like that with a lot more usability. But so instead of these options down here, what I can do is I can change the cooldown. If I go into here and do interactable cooldown, if I can now go down here and do cooldown, interactable cooldown per agent, success limit, interactable duration. I can change all the different options in here if I want. I can do this, but only interacts once. I can do a cooldown of 3 seconds, cooldown per agent 3 seconds. I can also enable this. And it's also important to mention that the interactable components needs a mesh to work. So if I don't have this cube here, it won't work. But what I'm just going to do is I'm just going to make it so this cube is not visible or collidable. So if you in-game, you'll be able to walk up to this and you can see the interact. And the next thing I'm going to do in this is that I'm going to add in a light component. So this is going to be the light that I control. I'm going to go over capsule light, and this will turn on and off if I press it. So yeah, there we go. We'll see how that goes. And also what I'm just going to do is this verse component, I'm just going to delete it so we're not going to be using it. And what we're going to do, first things first, is we're going to go into verse. We're going to go into verse explorer, and we're just going to make a new verse file, scene graph components, and this is going to be where we're going to put all our logic for interactable components. So because right now the component has pretty much no stuff in it except for a few things. If you actually press the button, it does nothing, has no like it doesn't work. So we need to add in functionality for it. So what we can do is we'll do interactable. It's going to dynamic components. So I'm going to do enable. So we can enable, and this will add functionality to the button, so we can enable and disable it, press it or not. And then we can do component. There we go. And then I'm just going to create. This is going to create a new verse component right here. Now we have our new verse components. So we're just going to click into it. Now the interactive component has a lot of features that I want to use. Okay. But the problem is that right now this interactable component, our enable component that we've made, is not a interactive component. It's just a regular old component. So it's not getting all the stuff because we're not inheriting or extending. We're only extending the component class, not the interactable class. So to actually do that, we want to add an interactable here, underscore, and now we're expanding the interactable component. Now we could also do basic as well if we wanted to. I think I'm gonna do basic because then you can get all this stuff. Anyways, okay, so inside of our code here, we want to add in all the functionality that we can actually use inside of this interactable. Now this component is going to be something we can duplicate for future buttons we can use, and we can make completely new buttons that do different things using the baseline of this, which is using the baseline of this. So which is going to be this new component class that is inheriting or an extension of basic interactive component. So we need to add some logic. Now first things first, we're going to have to get using Fortnite.game, Fortnite/game, whatever it's called, /Fortnite.com/game. With the use of this,
That will give us all the details about the round and everything. Because we're gonna have to enable, disable this one end of round and stuff like that. First thing I'm gonna add in is 2 messages. We're gonna call this enable text, and we want this to localize. Once we got this, then we want to do its type, which is going to be a message. And we're going to equal that to a message string. That's going to be the text that you see when the light is turned on. So we're going to want to call it turn off, because we want to turn off the light or turn on or something. We're going to copy this, and this is going to be our disabled text, and this is going to be turn on. So when we look at it when it's disabled, it's going to say turn on, and when we look at it when it's turned off, it's going to say turn on. And okay, what we're going to do is that we're going to use on begin simulation and on end simulation to add and we want to add and remove functionality to our buttons so they work like how they should. Now, okay, so the scene graph components work differently to creative devices, where they simulate when on begin simulation, and they can, you know, go until the end. But if you're not careful, there can be problems where your game might crash because you're using up too much memory because you didn't disable some scene graph components or something like that. Now, to actually handle this, what we're going to make is a cancelable variable. So we're going to have to make a few cancelable variables. So we want to make var round started handle. And I want this to be public because we're going to use it in a different class. And then we're going to make this of type cancelable. Okay, now this little like question mark here means that it's an option, okay? It can store something or not. So it can have either something in it or something not in it. And if there's nothing in it, then it's going to be equal to false. So what we're going to do is we're going to equal it to false because we don't want it to be enabled first. Then what we're going to do is we need a round end one as well. So we're going to get round end. So we're just, instead of round started, we're going to get round ended. That's going to be the exact same thing. And then we're going to get another one, and we're just going to call this third one succeed event. So this will handle when the button is succeeded. Next thing we want is something to store the state of our interaction. So it's pretty easy. Just is interact enabled. And we want to protect this because it's going to be important, and we don't want melding with our beautiful variables in our class. And then we're going to make this of type logic, and we're going to equal that to true because we want this to be enabled when the simulation begins. Okay, now what we then want to do is inside of here, we want to subscribe these cancelables, these two specifically, to the start of the round and to the end of the round. So these will change depending on if the round is started or the round is ended. So then we can control if the button is enabled or disabled at the start or end of the game. So what we're going to do is we're going to do if, and then we're going to grab the round manager, which is what we got from the Fortnite.game. Oh, sorry, this is not the round manager. This is something we're going to call the round manager. Now we're actually going to get the round manager. So we get entity get fort round manager, and it's going to be a bracket. And then inside of this, again, we're putting in an if because of the failure context, whatever it's called. Now we want to do round started cancelable, which is going to be a new thing we're going to make. We're going to make that equal to round manager dot subscribe round started, and then we're going to subscribe the function on begin round. Then we're going to set round handle or round started handle equal to the option, and we're going to put the round start cancelable, whatever that becomes, inside of there. Okay. Anyways, to explain this, okay, what we're doing is that from this entity, we're getting the fourth round manager, okay? If you hold control and click on this, it's telling us that it's going to return the round manager from the simulation entity, which is what we want. Then with the round manager, we're going to equal that to round manager, so then we can just use it there. Then we make a new variable called round started cancelable. Now this will store the states of round manager subscribe on round started begin round. And this means that the subscribed callbacks will be invoked in 2 scenarios: when a new Fortnite round starts and if a round is ongoing. Then upon the round ending, all callbacks will be cancelled, which is good because we're using a cancel. So we're going to just put in our function that we're going to subscribe inside of our round started on begin round, because then we can detect on when the round begins. The last thing we do then is our round started handle. Then we're just going to equal that to the option of round started cancelable, which is going to give us, which is going to change this to true, or when the round begins. So we'll know the round has started, I do believe. Now then after this, we're going to do the same thing, but for the round ended. We want to make a round ended cancelable. Round ended cancelable. We're going to equal that to round manager dot subscribe. We don't have to get the round manager again because we already have it. Round ended, and we're going to use, instead of on begin round, we're going to make a new function called on end round, which is going to be something we're going to make in a. Then we're going to do the same thing. We're going to do set round ended cancelable, or round-ended handle, and we're gonna set that we're gonna set that equal to the option, and we're gonna put in our round and then cancelable inside of there. And this does the exact same thing that this does, but just for the round-ended. Now, okay, now we actually need to cancel our stuff at the end of the game. So what we can do is we can make a new function on end simulation, which is an inbuilt function already in this. What we're gonna do is we're gonna do override. This is a function I believe built into the components class itself. It's not working. Let it wrong. I'm sorry, I spelled override wrong. There we go. Now, okay, just like this, we want to do a super, and then we'll do, instead of on begin, we'll do on end brackets. There we go. And then inside of here, we're going to kind of do the exact same thing here. We're going to set a round started handle and a round end handle to, we're going to cancel them because it's the end of the round. So what we can do to do this is we're going to do if round started cancelable, and we're going to do if that is equal to round started handle, which is going to be our cancelable option. We can then call the option by this, so it's going to see if something in it, and if it is equal to it, what we then want to do is we're going to do round start cancelable, and what we're going to do is we're just going to do dot cancel, and we're going to cancel that. Sorry, put a colon there and also make a ed, and there we go. We also then want to add in one for our start, so we do round, or sorry, ended. So we do round ended cancelable, and we do equal to round ended handle. So you check that, see it's inside of it, and if it's equal, which it probably will be because it's going to be the end of the round. So round ended cancelable. If you remember from up here, we're seeing all this. We're just going to do round started, round ended, sorry, cancelable. And we're just going to cancel it. There we go. Now, okay, you got to also remember that this on begin simulation, that's not on begin the round, that's on begin simulation. And this is on end simulation, not on end of the round. These will be on begin round, on end round. So these will happen when you press the start game button in your map. Because again, we're getting the Fortnite game, and we're going to, that's how we just know. But anyways, to actually make these functions, what we're going to do is we're going to do on begin round. We want this to be protected. We want it to be, then we're going to make it a void. And then inside of here, we want to set succeeded. This is where succeeded event handle now comes in. We're going to make that equal to the option that's known as succeeded event. We're going to subscribe on succeed. Put that wrong. Again, succeeded. Okay, succeed. There we go. Yeah, and then this is succeed. Oh, I got it mixed up. There we go. Okay, so anyways, so a succeeded event is we're inheriting that from the interactable components. So if I go into interactable components instead, it should be in here. Let's see, succeeded event. We're using that to know when the when the interaction is complete successfully. That's how we know. Because again, we're inheriting or we're extending the interactable components. So we can use that event from all the way in the interactable component in our component, and it'll work fine. Now, okay, that's it for on begin round. Now, all we need now is our function on succeed. So we're gonna have to make that. But anyways, so the succeeded event, but we also need we're gonna have to make our on succeed. So it's pretty easy. But before we do that, we gotta make our on end round as well, because we also end it on the end round. It's also been protected, and then we're going to make that void equals colon void equals. Okay, in this one we'll do if, and we're gonna get our succeeded event cancelable. We're gonna make that equal to succeeded event handle, which is what we made earlier. And remember, this is an option. It contains either contains false, so nothing, and I'll just pass it, or it will contain something that allows it to cancel. This will open it and see if it's the same thing as this. Once it's opened, then God, did I spell it wrong again? Succeed event, succeeded. All right, there we go. Inside of here, then we want our succeeded event cancelable to then be cancelled. We don't want it to, exist anymore because it's on the end of the round. So this will just cancel this, so which is what we want. So we've canceled everything. So now we can just make our logic. So now we actually make our function on succeed, which is going to play when the button is on succeeded, or on the success event, whatever it's called. We want to make it protected, and then we want to grab an agent because there's going to be an agent who's going to interact with this button. So we can get the agent of the player into here. If you look at the event, if I go into, where is it? If you see in here, should be in the succeed event, it's a listenable, and I need an agent. So we're gonna have to we're gonna need an agent if we're going to use it. So we're gonna put an agent inside of here. Get rid of the agent. I don't think it'll work. But anyways, okay. First things first, we want to do if, and we're gonna grab something called is interacted and enabled. It's something built into the class, and we're going to see if it is enabled. Then if it is enabled, we want to set is interact enabled equal to false. So now if someone interacts with it,
And if interact is enabled, if it is enabled, then the interact will be enabled. It will be equal to false. Now, if interact isn't enabled, then what we can also do that you can set is interact enabled. You can set that to true then. So it's the opposite. Oh my god, I keep spelling it wrong. My spelling's terrible. I do this for hours, bro. Okay, now this is almost done. Last thing we just need to do is set up our. We can get rid of this at the bottom. Last thing we want to do is we want to set up our logic for our message. So we want to do interact message override. We're going to override the interaction message agent. It needs an agent. We want to do decides reads message people. And we're going to put our, because we're going to return a message when we call this function, so our enter message. Now the reason why we make this is because we can use this to override the UI text depending on what we set up here. So that's why I made these up here, because then we can then use these texts we've made inside of this message, which allows us to change what it actually says. And by the way, you can also make these editables, and you can change them through the component as well if you want. Fun little fact. But anyways, if is interact enabled, do this. This it's literally the same thing. We're going to return enable text, and this is going to be the text that we're going to be using, which is from up here. This one right there, enable text. And since we need to return a message, let's have a message, so we can return that. What do else? And then I do return disabled. Oh, then that works then. Okay, I think it was just an error. There we go. Oh yeah, I think it's because I needed another thing, because this could fail and then it will work. So I need another return to make sure it also returns something else. Okay, it's fine. All right, anyways, okay, so this is the end of our button behavior. This is all we're going to need for the interactable, but we're not done yet, okay? If we want to actually change our light, which remember, that's our goal in the first place, we've now built all of our interactable, like, you know, behavior for a button. Now we need to use this behavior to make a light interactable. Okay, now what we're going to do first is we're going to go to our Verse Explorer, and we're going to create a new file, sync our components, and we're going to call this our interactable light. We call it like something like that, and we'll call it component and stuff. Now this is going to be our final, you know, built up code. It's going to use all the bases we've made. It's going to use the component class. It's going to use the interactable. Then it's going to use the basic. Then it's going to use our enable and components. And it's going to build all of that up into this now. So we're going to now create it. Now once it's created, you're going to click inside of it. And okay, once you're inside, we're just going to clean it up like usual. In this one now, okay, instead of, we're going to need to inherit from our other one we just made. Now, instead of making it inherit from the interactable components, we're going to make it so it interacts from our one we just made. So it's the interactable, it's going to be our enableable component, the one we just made. So we're going to inherit all that behavior into this class, which is our new class, which is going to be our interactable light. Now we have all the stuff we've built already from here, and we can use it inside of this. Now the reason why you want to do this and why you want to build it like components like this is because you can then use this behavior that we've made here in anything. So instead of doing it for a light, you can make another component that's for a different thing, like a mesh, or I can do something different, and you can change it, and you can use all the behavior you've already made from there, and then you can transfer to different projects, and you can use it like that, and it all builds up, and it's very, very nice. But anyways, really, the more stuff you make, the more reusable stuff you have, the easier and faster it is. You will be able to create cool mechanics and build off those mechanics and make new things and stuff like that. That's the beauty of Scene Graph. At the end of the day, you don't actually really understand how this works. You could just copy it, and then from there you can then just use it as like a black box, so just do whatever you want. You probably should understand how it actually works though, but you know, that's just something you could do. But anyways, okay, who cares? Onto this part. Now, instead of our new components, what we're gonna do is we've already got our components out of here. Sorry, I got a bit sidetracked. I lost my train of thoughts. We're going to make it editable, and this is going to be our light, okay? And this is going to be our light entity, and this is going to be of type. We're going to make it public, and this is going to be entity. So then we'll be able to go into our editables and add in a light entity like that. Pretty cool. Now, okay, what we can also do is we could add in more text that overrides this text in here. So this and over here, our enabled and disabled text. What we can do is we can bring this in, but we can override it. We're gonna do override, and then we can override the class, and then we can make a new message. Sorry. And then we can do it like turn a light off instead, turn light on. And you can override it if you want to whatever you like in here. Because again, we're inheriting, or from this or extending out from this interactable enable component, so we can use all the stuff from there instead of here. Alright, so next step is that what I'm gonna do is I'm just going to get rid of onBegin simulation because we don't actually need it, and I'm going to actually grab our older function we had, which would be onBegin round. So we do onBegin round, and then we also want to override it because we were using it, and we're just gonna override the functionality of it, make something new with it. We want to void is equal to, and then in here we then want to make a super on begin round. And if we don't know what this does or super, basically we're just adding in it. We're just using all the stuff we've already made. If that makes sense. So we're going to get the class above it. So right now we're getting the onBegin from interactable enable components. The reason why we put it here is because onBegin simulation is from the basic interactable components, or actually no, it's from the component all the way up here onBegin simulation. So if you want to use stuff that traces back, you want to use super, helps out if you want. But anyways, okay, so it's going to play the onBegin round, which is all the logic inside of here, just this. But anyways, so the next step is that we want to initialize is enabled depending on the current state of a light component. So if the light's turned off, is dark enabled is. If the light's enabled, then the interact enabled is enabled, and if it's not enabled, then the is interact enabled is not enabled. So to do that, it's pretty simple. All we gotta do is do if, and we're gonna make a light types capsule light. Or we can just do lighting. You can be more specific, but I'm just gonna use a super class. It's easier because I'm only gonna have one light. If you have more lights, like different kinds of lights, use the specific thing. And we're gonna do light entity get components. And that light entity again is our entity that we've added to the enable or editable. And then inside of here, then we're going to use the get components, and we're going to find every single light component inside of our light entity, which is going to be just one because you can only have one of them inside of our light. Or it's not going to be one, but we can. You know what I mean. Anyways, okay. With that now, what we can do is we do if light is enabled, which is a logic thing we can check because it's built into the light component. We do set is interact enabled, and again interact enabled is from our, I think it's from the interactable component, else set is interact enable false. So basically this is going to check the state of the light, and if it's on it's set it to true, and if it's off it's set it to false. It's pretty simple. So I just realized I spelled this wrong. I'm using insert. There we go. Perfect. Alright then, okay, after this we then want another function for onSucceed, and again we're going to override this. We're going to pass in the agents we got from earlier. We do void equals, and now what we want to do is we want to enable disable the light depending on if the light component is disabled or enabled. We'll do if light, okay, I put that wrong again. onSucceed, there we go. If light, sorry bro, it's been a while. Okay, I'm tired. Okay, I gotta be honest. I haven't did this story forever. Okay, we're doing if light components equal to light entity get component light component. It's pretty much the same thing we did earlier, so I don't really explain it. Light components, there we go. Then okay, this is just gonna be the exact same thing, is interact enabled. Basically when the button is on succeed, if the interact is enabled, it's going to disable the light, and else isn't else light, so it's going to then enable the light. There we go. Then what we want to do at the very bottom here, we then want to do super, and then on succeed agent. Now we look at that, if just like this, and now our code would be done. Now we have all the functionality we need for our light to work. A light turns off and on, depending on it if it's interact enabled or not. Alright, so all we gotta do now is build this. Now back in UEFN, finally, we just want to go into our cube prefab, and then inside this entity, I think what we should do, if I go into components, we can find our interactable enable our light component right here. We'll add that in, and if you find it right here, there is it. Oh yeah, and also by the way, sorry, it's not adding to it because we already have a basic interactable component. We just wanted to remove that component because again, this is inheriting from it, so technically it's also an interactable component. So there we go. We'll add that in now, and then we have our. And by the way, this is the interactable component. So you can have all the code on and everything. But if I were to add in the one we just added, which was the light interactable light, we now have the light entity we can now add in. Again, it inherits from all those previous components. Okay, to actually add in our light entity, we're going to select an entity that has a light in it. We can select the one we have right now, or we can make a new entity. And then instead of this, we can then do as a child. And we're going to call this light. And instead of our light, we're going to add in, I don't know, a capsule light. There we go. And here's our light. Then what we're going to do is we're going to then, instead of our cube prefab, I also have basically interactable in there. I gotta get rid of, and a cube also gotta get rid of. So then inside this entity, this is where our interactable will be. I'll just put it in there. You can put them in the same one, by the way. I'm just gonna make 2 separate ones, so change the position of one and the position of light, depending on the location of what is. But anyways, so we have our cube. Make sure you have a cube or a mesh or anything that you can make it non-visible or collidable. You need to have a mesh with it interactable, otherwise you won't be able to use it. Anyways, our light entity, we're gonna set that to light. So now it's light. So our entity that has a light in it is going to be light. Our cooldown, we can set to interactable cooldown, and we can set that to 3. Cooldown per agents, so that's 3, I guess. Success limits, that's how many times you can interact with it. I'm gonna do like maybe like 15. And then our interactable duration, then this is how long it takes to interact with it. What we can do is we can set that to 3. And we can also set a max simultaneous interactors. Or actually 1. And so I'm gonna set the 5 or 1. That's how many players get interacting at the time. So I'll do 5. And then we'll save that. And now this should actually be working. So if we go out and we launch a session, we should be able to go check this out. Also, what I'm also going to do is I'm going to add in a room so it's a bit darker because I can't really see the light. All right, so now if I just go into session, this is going to be pretty crazy, but it's not going to be anything crazy. But if you look up here now, if I walk up to here, we now have the option to turn the light off. That's what the interactive component does. It shows a little button, what we do. And as you can see, this light is currently here. And the mesh actually, I think I should have turned off the collision on. I don't know why I can still collide with it. But anyways, when I press this button, the light should also turn off. So if I press the button, would you look at that? The light's turned off. Oh boy. And after 3 seconds, the cooldown will end and I'll get turn light on, and I press that, then the light will turn on. So there we go. That's how you do it. That's how you would make a light to turn off and on. Pretty crazy stuff, I know. Now this is using an interactable component that I've expanded interaction component to have functionality and also be able to interact with this light as well. I imagine like you can do this with anything, so you can expand a light component, you can mesh component, you can expand the sound components, and you can make them work however you like, as long as you just know how to do it. So yeah, it's pretty powerful. Now, of course, since this is scene graph, okay, the beauty of it is that you can actually just go into here and I can just drag out my keyframe and I can just place this light anywhere. So now if I go back into game, ignore that how there's a cube there, but now I can just walk up to any of these and I can just turn them off and they'll all work for every single one. All of behavior will still work, and I can duplicate this as many times as I like and it'll all work, and there's basically no memory usage. It's actually so helpful. I honestly don't know what's going on with that one, to be honest. So yeah, that's some pretty good stuff right there. So yeah, that's how you would make a button that turns on and off a light. Now, like I said at the start of the video, before the video ends, I'm just going to go through all the known issues that SceneGraph currently has. So I'm just going to read them down. I'm just going to go through them all. Following are known issues when you work with SceneGraph in your project. If you have any feedback or find issues are not captured in the list below, report them to the forums. So if that happens, do that. Anyways, okay, let's get started. SceneGraph is a beta feature, and you might encounter unexpected crashes and instability. Light components in entities do not display lighting wireframes. The workaround for this is to reselect an entity in the viewport to get visualizers to show up. You cannot clear all overrides from a prefab instance at once. You must clear each override one at a time. Entities do not use the one file per actor system. Instead, entities are saved in the UMAP asset. If you use URC with your project, you will consistently lock the main level and disable the ability to collaborate on your project. There are no way to save overridden prefab instances to the prefab assets. Duplicated entities are not named correctly in the prefab editor. Expand all and collapse all do not work on components. There is currently no way to remove overrides from a prefab. By clicking the override icon should have the same effect as a left click. You cannot detach a child entity by dragging it onto its parent. Disturbing the static mesh component rotation along the left axis causes unexpected movement. There is unexpected player behavior when colliding with SceneGraph objects. Once an entity has been manually renamed, the entity name cannot be changed again. Negative scaling can cause abnormal interactions in child entities when rotated. Dragging transform values in the prefab editor is slowed and less performant than changing values from the widgets. Entities in the prefab editor are not always selectable. Deleting a prefab creates a ghost prefab in live edit sessions. Prefab assets do not have thumbnails. Component logic runs in both edit and play modes. Components are initialized much earlier than creative devices, which means that trying to fetch a creative device from component on begin simulation or a component on simulate will not work. To work around this, you can loop and sleep until components are found, or you can spawn your prefabs from the creative device's on begin call. The ability to hide selected entities in the level editor hotkey H and prefab is not working. Changes made in the prefab editor will not propagate to placed instances of a prefab unless you have saved your changes.
Saving the project while verse code is not compiling can result in corrupted prefab data. Running verse asset digest generation for the first time can be slow. When you copy and paste or duplicate a prefab in the level editor, descendant prefabs and descendant entities that belong to the base prefab asset will be incorrectly marked as fully overridden. Mesh, sound, and particle effect components are only generated in verse for assets you import or create in your project, along with a small selection of built-in mesh shapes. By default, you can't use Fortnite or fab assets with SceneGraph. When you import a new mesh or sound to your project, or you create a new particle system asset, you must build verse code for your project to generate a component class for the asset before you can use it with the SceneGraph system. As you add and change parameters in the material or Niagara editors, you will need to build verse code for those changes to be exposed into the level editor. If you move, rename, or delete meshes, sounds, or particle system assets in the editor, it is possible to lose references to the generated component instances in the level editor, as the classes that are generated currently cannot utilize redirectors. Asset generated components are not generated until you have at least one buildable verse file in the project and compile verse. SceneGraph is shipping without redirectors. Without redirectors, renaming assets can trigger either the following of two scenarios. Objects referenced by other objects in the details panel will have the references break. This will require them to be set back up. Objects referenced in verse code will trigger compiler errors, and their references will need to be manually updated. The new LUF coordinate system affects existing content and SceneGraph content. Any existing verse code will continue to work. However, if you want to use a sync code with SceneGraph, you'll have to convert to the old Unreal Engine temporary spatial map types, verse.org spatial map types. There are new conversion functions that can transform between all new types, from vector 3, from scalar 3, from rotation, from transformation, and there's a little snippet right there. Enabling SceneGraph changes some of the code generation rules for classes generated to assets digest first. This could mean that existing verse code would no longer compile. You'll need to fix up verse code before proceeding with your project. This is before SceneGraph, after SceneGraph. Both the tech component and the scene event systems are still being iterated on and still experimental. Avoid using these features if you want to publish items containing SceneGraph code. A simulation entity will not be available unless a SceneGraph entity has already been placed in the level. There is a problem with verse classes referencing prefab classes in their member variables. It results in an error message when starting the editor. You'll get an ensure from the static allocate object that you're trying to create an instance of an abstract class, and the class is object. This static allocate object is called the $init CDO of your verse class. Changing the type of default object in the verse component class between an entity copy and paste will end up importing the reference of an instance of all type, even though the property wasn't overridden. Reloading an entity prefab asset with an added entity child triggers an ensure old to new value has any class flags class token stream to assemble. Recommend only one person at a time is editing SceneGraph, so that's kind of also very important. Only use admin permissions for the creator team creates new URC repositories for new projects. Those are all the known issues. Hopefully that helps you understand if you're having any issues or if some features are unavailable. All these things here, I'm going to presume are going to be fixed in the future, including the fact that you can only use, imported or generated things for your thing. So Fab and Fortnite assets are not available right now, which is kind of annoying, but it is what it is. Okay, I gotta be honest with you all, guys. Okay, I was going to go into more. I was gonna talk about more stuff in this tutorial, but I had so many issues making this. So I'm not going to finish it for now. Okay, this is going to be like the beginner's guide to SceneGraph. I'm going to make a second tutorial that's going to go over more advanced things like spawning in props, transforms, keyframe movement, like detecting, like sweeping with like a volume, and of course scene events as well. So I'm gonna go into those in the future, but this should be good for now. Okay, I hope you're satisfied with this. It's already been so long. It's been like 2 weeks. So I want to get this tutorial out so all of you know how to use SceneGraph as quickly as possible. But anyways, I hope you enjoyed the video. Remember to like, subscribe, use my code in the Fortnite shop, and thank you to everyone who's a member of the channel. And remember to watch all these videos for more of my tutorials. That's about it. I'll see you all around.